All right, so before we look at lesson 7.5, I just want you to do some review problems. So now that you can see the problems on the screen, please do these on your own. Pause the video and then do these on your own, and then you can unpause. All right, so the first one, they just want you to write the expression in exponential form or radical form. So this is square root of 8. So that means it's in radical form. There's really a 2 here and a 1 here. So in exponential form, this would be 8 raised to the 1/2. This one is really 3 times y to the 1/2. So the 3 does not have an exponent, so that's going to stay a 3. And then this would be a radical. The 2 would go on the outside and y the first on the inside. We would not leave it like that, so your answer would be 3 square root y. Number 3, they are both in the radical. So there's really a 2 here and a 1 and a 1. So you can kind of do this in 2 ways. You can write this as 2 to the 1/2 and then x to the 1/2. We don't want to write the dot. Or you can write both of them together, so 2x together would be raised to the 1/2. Either, if you write this way, you have to have the parentheses. This one is kind of like that, so 5x is in the parentheses, so that means I want both of them in the parentheses in the radical. The denominator is your number that goes out here, the index, and then your exponent there. You can also write this one as cubed root of 5 squared and x squared. What you don't want to do is simplify, or what you could simplify the 25 if you want to, but you really shouldn't. So either of these would be correct. All right, so same thing with these. Now they want you to actually simplify these. And remember, these you can simplify in a variety of ways. So pause the video, try these 4 problems, and then you can unpause and listen. All right, so we've got the 4th root of 16. So remember, you can use your calculator if you want to do the 4th root. You can simply figure out, this means that I need to figure out what times itself 4 times gives you 16. The answer is 2. And remember, you can also take 16, there's really a 1 here, and write it like this, and then use your exponent button. But the answer is 2. This one, again, you can write it like this if you want, 5th root of 243, and use your calculator, or you can use your calculator exactly what it says. 243 raised to the 1/5 is 3. So either way, your answer should be 3. There's lots of ways to get that answer. This one, same thing, lots of ways to get your answer. You can rewrite it. This is the same as 27 raised to the 4/3. So if I type in 27 raised to the 4/3, I end up with 81. The other way to do this one, there's lots of different ways. You can figure out what 27 to the 4th is, and so then it's really 3rd root of 531, 441, and then use that 3x root button, and you're still going to get 81 regardless. And then the last one, this would be the easiest way to do this one. This is to bring it in using those properties. So this is 1 to the 5/3 over 27 to the 5/3. Well, 1 to the 5/3 is just 1. And then how you figure out 27 to the 5/3, the easiest way is to type in your calculator, 27 raised to the 5/3, and you get 243. So 1 over 243. No decimals will be accepted for that one. All right, so then the last one, same thing, pause it, try it on your own, and you can unpause it. We need our bases to be the same. So this left base is already 5, so 5 raised, the 2x minus 5 has to equal. This is the same as 5 to the 3rd, so we're going to rewrite it as 5 to the 3rd. Now that our bases are matched, that means that our exponents also equal each other. So 2x minus 5 equals 3. So then we can add 5. We get 2 times x is equal to 8, which makes our x value 4. All right, so exponential functions. Now there is some graphing involved in this lesson. So there are options for you. Your homework is a worksheet. So when you get to the homework portion, you can either print off the homework worksheet and then use that to do your homework and do your graphs and things, and then upload that. Or you can print off the graphing template that I will put in here and print that off and do your graphs there. If you choose to just do the graphs on your notebook paper, then you're just going to draw a coordinate plane, okay? And we're perfectly fine with that if you don't want to, if you don't have the capability to print or you don't want to print at home. Just draw it on your notebook paper. So definition, an exponential function is a function of the form y equals a times b to the x plus c, where a cannot equal 0, b has to be greater than 0, and b cannot equal 1. So we saw exponential functions I'm sorry, we will see exponential functions, more about them in 7.6. Sorry, I started to say we already saw them, but that's because I did the video already. So a couple of other things. The base b is a constant, so anytime you have a number with an exponent, that is your base, is what that's referred to. It's a constant, so that's just mean that's not what's going to change. So this will stay the same, it'll be constant, and then your a and c will change. The exponent is a variable, that's what makes it an exponential function. And then they are not linear. So if you draw the graph and you get a line, you did something wrong. Okay? So then the one other thing you need to make sure you know, and I think, oh, there we go. So it will approach the value of c. So when you graph an equation, your equation itself will kind of get closer and closer to c, but not ever touch or actually arrive at c, okay? So your range would be all real numbers y greater than c, and we'll talk about range and domain in a minute. I'm sorry, and domain is all real numbers. All right, so most of the first examples are going to ask you to graph. So here's your first one. So graph the equation, find the y-intercept, and state the domain and range. Okay, so like I said, you can just draw a coordinate plane if you want. So basically, you need to make a t-chart. So we're going to make a t-chart. It's really the only way to graph these. So pick some negatives and some positives for your x values. That's the easiest. And then you just type them into your calculator if you want. So 3 raised to the negative 2. You can also do this by hand. 3 to the negative 2 is the same as 1 over 3 to the positive 2, which is 1/9. So you end up with 1/9, which is actually 0.1 repeating, and you can write it like that because we're just graphing them. So then if I put negative 1 in, 1 over 1/3, you get 1/3, so 0.3. If I put 0 in, negative 3 to 0, anything raised to 0 power is 1. So negative 3 to the 0 is 1. And then the rest shouldn't be that bad. So if I put 1 in, 3 to the first is 3. Put 2 in, 3 to the second is 9. So now I just have to graph it. So negative 2.1 is pretty close there. Negative 1.3 is also pretty close. 0, 1, 1, 3, and then 2, 9. And then we're going to graph it. Now I'm going to start with the first one I did. So it's kind of a curve, and I'll draw it a little bit better off. And then this is going to approach this line, but not cross it. I know it looks like it crosses. So there's really a plus 0. So that means it's going to get closer to 0, but not cross. Okay, so now they want us to state the y-intercept. The y-intercept is 1. Okay, you can also write 0, 1. Your domain is all real numbers. Now you can either write this or you can write out all real numbers. Okay? And then your range, you have to have all real numbers. So all real numbers, or you can write out all real numbers, y greater than whatever your c value is. So whatever they're approaching 0. So here would be the second part of your answer. So y-intercept, your domain and range, and then your graph would be your answer. All right, so we're either going to look at the next one or skip to C. I can't remember. We're going to skip to C. All right, so this one says we've got the function, the equation y equals 1/3 to the x. So it starts off the same. You're going to make a t-chart with your x values going from negative 2 to 2. Okay, so again, you can use your calculator. 1/3 raised to the negative 2. It's not going to give you a negative number. This is the same as 1 to the negative 2 over 3 to the negative 2. And if we deal with our exponents, we're going to move this one to the top, it becomes positive. We're going to move that one to the bottom, it becomes positive. So you end up with 9 over 1, which is just 9. So if I put negative 1 in, these all become negative 1s, and then this becomes positive 1, you end up with 3 over 1, 3. Your calculator should get those same correct numbers as well. Okay, if I put 0 in, 1/3 to the 0 gives me 1. And then for 1, 1/3 to the first is going to give me 1/3, or 0.3 repeating. And if I put in 1/3 to the second, that'll give me 1/9, or 0.1 repeating. And whether you write repeating or not in the t-chart does not matter. Okay, so now we just have to graph it and then answer our 3 questions. So Again, if you look at this equation, there's nothing being added or subtracted. So that means it's just like adding 0. So -2, 9, -1, 3, 0, 1, 1.3, and 2.1. So when I draw this graph, whoops, here's my graph, and then it's approaching 0. So I don't want to go across that. So they're kind of like this. This is not a very good draw of it. So then your y-intercept is 1. And then your domain, so your domain is all real numbers. Okay? And then your range, again, you need to state all real numbers. And then it's y, because that's what your range is. And in this case, it's still approaching 0, so greater than 0. So there would be your answer for that one. All right, we're going to look at one that's a little bit more complex. So here's letter D. All right, so letter D, we've got a bigger equation here. So again, we're going to do our t-chart. -2. All right, so 3 times 1/2 to the -2 minus 1. This comes first, so this is really 3 times 1/2 to the -2. If you use your calculator, will really be 4. So you really have 3 times 4 minus 1. So 3 times 4 minus 1 gives you 12, minus 1 is 11. So then if I put in -1, you're going to get 5. If you put in 0, you're going to get 2. If you put in 1, you're going to get 0.5, and 2, you're going to get -0.25. So -2, 11 goes off the screen here. -1, 1, 2, 3, 4, 5, 0, 2, 1, 0.5, and then 2, -0.25. Okay, so C is -1, so that means it's approaching -1. Okay. So don't forget about an arrow. So your y-intercept in this case is 2. Your domain is still all reals. And then your range is all reals, y values greater than your c, which is -1. So there would be your answer for that one. Okay, so exponential growth functions. So now we've already kind of had these definitions. So it is a function of the form y equals a times b to the x, where a is greater than 0 and b is greater than 1. So again, we kind of had these. The only difference is going to be it might be f of x. And then we have exponential decay functions. So a function of the form y equals a times b to the x, where a is greater than 0, and now b is between 0 and 1. So 1 is a decay, 1 is a growth. So what is going to happen? So here's what they're going to look like. So the function v equals 25,000 times 0.82 raised to the t models depreciation of the value of a new car that originally cost $25,000. V represents the value of the car, and t represents the time in years from the time the car was purchased. First question, what is the value of the car after 1 year? Well, if it's asking you after 1 year, t is the time the car was, is the time in years. So that just means that your t is going to be 1. So your value is going to be 25,000 times 0.82 raised to the first. Well, order of operations, you do the 0.82 to the first and then multiply. So 25,000 times 0.82 to the first is just 0.82. So then you end up with 20,500, which is what it should be. Give me 1 second. Yeah, sorry, my notes had something else. So this would be your answer. So again, this would be your work and then your answer. And then it asks you to find the value of the car after 5 years. Well, really no different than that first problem. So now your t value is 5. So v equals 25,000 and then times 0.82 to the 5th. So now you're going to do this first. So 0.82 raised to the 5th power gives you a big long decimal. Keep that on your screen, then press times 25,000. And you end up with, and we're talking about money, so two decimal places, $9,268, and it's 0.496. So if it's 0.496, that means this is going to go to a 0 and then a 5, so 0.50. So again, this would be your work, and then you'd have your answer. The next thing they're going to do is they're going to give you a T-chart basically and ask you to determine whether it is shows exponential behavior or not. Right? Yes or no. You do have to explain. So again, if you just write yes or just write no, you will not get any points for this. So there's a couple things you can do. If it has a slope, so a constant change by addition or subtraction, then you're going to be it's going to be linear. So if I look at this one, to go from here to here, we're multiplying by 1/2. And the reason why I'm writing it as multiplying by 1/2 instead of divided by 2 is we're looking for a multiplier. Okay, 32 times 1/2 gives you 16. 16 times 1/2 gives you 8. 8 times 1/2 gives you 4. And then 4 times 1/2 gives you 2. So this would be yes, and the explanation would be you are multiplying by a factor of 1/2. Okay, letter B, if you look at this one, 12 plus 16, plus 4 gives you 16, 16 plus 4 gives you 20, 20 plus 4 gives you 24, and so on. 0 plus 3, 0 plus 3, 0 plus 3, that will give you a slope. So it's a constant slope. They're changing by 4 and 3 by addition. There's no multiplier. We're not multiplying 12 by anything. So this would be no, and the reason would be there is no common multiplier. And if you don't write common, that's fine. There's no multiplier because they're adding 4 each time. Okay, so you could also sketch a graph, and you can see if you sketched this one, and it wouldn't have to be anything fancy, 0, 12, and then 3, 16, and then 6, 20, you'll see that it ends up being linear, whereas if you graph this one, it'll look like this. So you could always graph it quick to see that as well. All right, that is the end of 7.5. Again, 7.5 is a worksheet, and it does have some graphs in the beginning. So you either need to print off the worksheet and write it on the worksheet and use that to upload, or you can view the worksheet and use the graphs sheet of paper I gave, say that again, or you can read the worksheet on the computer and write it on notebook paper, just draw a coordinate plane like I did here. So what you're going to see next is actually the end of the movie notes from lesson 7-3. Part of your homework today is going to be some of those problems we did not give you yesterday. So you can either continue watching now, or you can go back to 7.3 and look at those notes. It's basically solving equations with exponents. Is an exponential equation. So an exponential equation is an equation that has an exponent that is a variable. So as long as the variable is in the exponent. Okay, so here's your first one. I want you to solve the equation. Again, you need to show work. So the key with these is make these numbers, the non-exponent numbers, have the same base. And it's always going to be the smaller one. So 5 to the x equals 125. So I'm going to keep my 5 to the x, and I'm going to rewrite this so it's a base of 5, which would be 5 to the third. So you'd have to figure out, you know it's not 5 to the second, and then 5 to the third, you just type it in, you get that. So now that my bases are the same, this means that my exponents are equal. So that means x has to equal 3. So the key is getting the same base. Okay, you're not always going to know all of them. Okay, so this one says 6 to the what equals 7,776. So my key would be to get the same base. So I'm going to keep this 6 to the x, and then I have to figure out 6 raised to the what gives me 7,776. Well, I know it's not 6 to the second, because 6 to the second is 36. So that part you can figure out. If you don't know the rest, then you type it in. So we know 6 to the second is 36. I just typed in my calculator, 6 to the third, you get 216. I know it's not that, so I'm going to jump one. I'm going to go to 6 to the fifth. And 6 to the fifth is 7,776. So I'm going to change that to 6 to the fifth. Now that my bases match, x equals 5. Okay, it'll get a little bit more complex, so let's look at letter C. So we've got 2 raised to the x minus 3 equals 128. So again, I want my bases to be the same. So I'm going to find a base of 2. So 2 raised to the x minus 3 equals, I have to figure out 2 raised to the what gives me 128. Well, I know it's not 2 to the second because that's 4. So I'm going to jump to something bigger, like 2 to the 6th. 2 to the 6th is 64, so that's not it. So I'm going to jump to 2 to the 8th. 2 to the 8th is 256. Okay, it's not that one. So it's got to be 2 to the 7th. 2 to the 7th is 128. So I'm going to change this to 2 to the 7th. So now my bases match, so that means my exponents match. X minus 3 is equal to 7. So this is called the one-to-one property. Bases match, so the exponents match or equal each other. Once you're here, we just solve this equation and we get x to be 10. You can always plug it back in and check it. Okay? So letter D, I want you to try, see if you can figure out letter D on your own. Actually, let's do letter D no, sorry. All right, so again, you can pause it if you want to try that one on your own. So this one, oops, we don't want cyan because that's going to be a nasty color. So 12 raised to the 2x plus 3, 144. So we want to change them both to 12. So the left side is going to say 12 to the 2x plus 3. So 144 is the same as 12 squared. So now my bases match. So because my bases are the same, that means my exponent of 2x plus 3 equals my exponent of 2. And now I just have to solve this. So I subtract 3. I get 2x is equal to negative 1 divided by 2. And my x is negative 1/2. As before, don't write them as decimals, write them as fractions.